Good morning, students. So welcome to all first year students. So I am handling basic electronics and electrical subject. Fine. So most of the students who are there in this class are from science students. So most of the students have done the basic things of semiconductor devices. So I am handling with the chapter semiconductor devices. Fine. So the semiconductor devices chapter I am handling, the subject is called as basic electronics and electrical, and it is semiconducting devices. So most of my students who are from science background, they have already done with these things, but still as per the syllabus we need to teach you, so I have to teach you. So I am teaching this one. Fine. So before going to the semiconductor devices, we need to learn some basic definitions. So what are the basic definitions we need to learn? So first of all, you learn the basic definition called as matter. So what is matter? So matter is anything, you can say anything which can have mass, fine, and occupies space. So let me give you one small example. So let us take this pen. This pen has mass, fine, and also occupies some space. If I keep this on my hand, it is occupying this much of space and it has some mass. Fine. The examples for matters is like matter exists in different forms. If I say solids, it is like iron. If I say liquid, it is water. Then if I say gas, it is oxygen. So these are some examples of matter. Then comes next elements. So what do you mean by elements? So it is a substance. It is a substance that cannot be broken further into a singular substance. For example, if I take an oxygen, so you cannot break this oxygen into further substances. Fine? That's why it is element. Example for element is oxygen. Then comes next compound. So compound is a substance which contain one or more elements. Fine. So compound is a substance which contain one or more elements. So example given here is H2O, that is water. So it contains hydrogen plus oxygen. So two amounts of hydrogen and oxygen will give you water and is called as compound. Fine. Then comes next is molecule. So molecule is composed of two or more atoms. Fine. So atom of most of the elements cannot exist by themselves. Instead, they are generally available in molecule. So molecule contains what? It contains two or more atoms. It becomes what? Molecule. First of all, what is atom? We need to understand what is atom. So atom is fundamental unit of matter. Fundamental unit of matter. Again, we need to go to matter. Fine, which has mass and occupies space. So atom is a fundamental unit of matter. Fine. So these are the basic definitions we need to check it out. Next thing is that so atom, the basic unit of chemical element. Atom are the basic building blocks of element and matter, as I have told. So an atom itself is made up of three kinds of particles. One is protons, neutrons and electrons. So atom is made up of protons, neutrons and electrons. Fine. Then comes an example for an atom. It is called as example for atom is helium. So a helium atom is a atom of chemical element helium. Helium is composed of two electrons. How much electrons? It contains two electrons, two protons and one neutron. It contains two electrons, two protons and one neutron. Next thing is What is element? Again, an element is a substance that is made up of one type of atom. Whereas here, example for an element is hydrogen. So hydrogen is made up of atoms containing single proton and single electron. If you change the number of protons and the element will be the different. Fine. So here compound. So compound is a molecule that contains at least two different elements. So previously I have given example of H2O. So H2O is a water. It contains hydrogen and oxygen. Fine. So here is example of water H2O. It is carbon dioxide, CO2 and methane CH4 are the compounds. These are all example for compound, that is water, methane and carbon dioxide. These are the example for compounds. So here the main thing you need to remember, all compounds are molecules, but not all molecules cannot be compound. Fine. Next comes Bohr's model of an atom. What Bohr has said about atom, Bohr's postulates or Bohr's atomic model. We can say also it is a Bohr's atomic model. So what Bohr has said, first one is electrons revolve around the nucleus. So this is what nucleus, and these are all red are electrons. So electrons revolve around the nucleus. Fine. In a definite energy levels called as orbits or shells in an atom without radiating energy. Without radiating energy. What Bohr has said, electrons revolve around the nucleus in a specified orbit without radiating energy. So first of all, an atom is consists of a positively charged nucleus at the center, and it contains electrons which are negatively charged, and these electrons revolve around the nucleus in a specified orbit. So you just take an example of our solar system, where sun being the nucleus and other planets are nothing but electrons. How all the planets including Earth also revolve around the sun in a specified orbit. You may say it is revolving like in an elliptical order. Fine, like that. The second one is, as long as an electron remains in a shell or a orbit, it never gains or loses energy. Unless and until these electrons will revolving around here, it does not gain any energy. Fine. The electrons can revolve in the nucleus only in a permitted order. I mean to say the electrons cannot go to this orbit and start revolving. So this electron has to be there here only and start revolving. Fine. So next, if an electron is given an additional energy, here it is. The gain or loss of energy occurs within the orbit only due to the jumping of electrons from one energy level to another energy level. Fine. What happens if an electron is given an additional energy or extra energy in the form of, it may be a thermal, fine, or it may be an electrical energy. So that electron will get some extra energy to jump from one orbit to another orbit. The angular momentum of an electron is equal to nh divided by 2 pi. So what happens? The angular momentum of an orbit depends upon the quantum number, and it is integral multiple of the factor h by 2 pi. So what Bohr has said here, the electrons are permitted to revolve around the nucleus in a specified orbit. When an external energy is applied to the electron, that electron will get a kinetic energy so that it will jump from one orbit to another orbit and it will try to become free. Fine. So these are the applications of Bohr's atomic model. So Bohr's atomic model is used for the derivation of radius of an orbit of an atom. Next one is derivation of energy of an orbit and derivation of wave number. Fine. So this is regarding this topic. Thank you very much.